So this is the second part of this theorem. We already looked at the two secants, sorry. And so now we're going to take this same theorem and look at what it looks like as a tangent and a secant. So you draw a circle, draw in a tangent line, draw in a secant line. Remember, the secant line has to touch circle in two spots, intersect in two spots. And we're intersecting outside the circle. Question, Alexis? No. Okay. All right, so we have intercepted arcs here. The intercepted arcs are this one right here, AD, and this one right here, BD. So we have half the difference of the intercepted arcs. First of all, what's our angle name?
ACD.
How much? ACD? Yeah. Sure, you can call it ACD. You could also call it what? BCD. So measure of angle ACD is half the difference of the intercepted arcs. So what are the intercepted arcs again?
What? AD and BD.
AD and BD. Which one, when we subtract, is going to have to go first? The bigger one, which is AD. Remember, it's always the furthest one from the angle. So measure of arc AD.
Right.
Difference means subtract minus BD. And it says half, so I divide it by 2. Okay, so this is what this theorem actually looks like. This theorem looks like the angle is half the difference. This is exactly like the examples that we did yesterday with the secants. So I'm going to forego doing extra examples with this one because really you'd have the same scenarios that you had yesterday. Now when we look at the third possibility, when you have two tangents, that one I'm going to give you some very specific examples on because that's the one that tends to confuse people a little bit. All right. Is there anybody still writing?
Yes.
Okay. Okay, we're going to move right along and take a look at what happens when we have two tangents. Okay, two tangents. So when you have two tangents, I want you to draw your circle. I want you to put points A, B, and C on it. I want you to draw a tangent to A, and I want you to draw a tangent to C.
And call it B.
And the angle is angle D or angle ADC. So you're not rewriting this whole theorem every time because it's all the same theorem. It's just that we're looking at the three different possibilities, tangent and secant, two tangents or two secants. So here we've got two tangents that we're going to take a look at. Now it's the same rule. But when you do the problems, you have to be careful to make sure that it works out. So here we have, here's the angle, ADC. It's going to be half. And what were my two, what are my two arcs here? Wait, say, Alvin, tell me the one arc is AB. Just AB would just go from here to here.
ABC.
ABC, that's this one. And we're going to subtract which one?
AC.
AC. So you need to take the major arc and the minor arc. In this case, what makes this one a little bit unique is that the endpoints of the arc are the same. It's just one is major and one is minor. So we have that. I want to go to the next one. Where are we? There it is. Okay, so this is what this looks like. Measure of angle ADC is measure of arc ABC and measure of arc AC. So you subtract and divide by 2. Anytime you have the intersection outside the circle, you're going to think the angle is subtract and divide by 2. If it's inside the circle, you think what?
Subtract and divide by 2.
If it's inside, you think add, divide by 2. Okay? So the outside ones are subtract and divide by 2. Alright? Okay? As the next thing we need to do is look at some examples, because these are the ones that, if there are any that tend to confuse people, these are the ones that sometimes people get a little confused about. What's your question?
How are the arcs and something that they
Here, it's where the point and the point, those are the endpoints of the arcs. So this line intercepts the end of this arc, and this one intercepts the end of this arc, the same arc, but then there's also another one. There's 2 arcs that are intercepted by the same angle. Okay, so let's take a look at a sample problem. Same scenario, you've got a circle, we've got 2 tangents, and the thing with these is it always almost appears as if you don't have enough information to solve the problem. Because we're only given one little piece of information, but you're supposed to subtract something and divide by 2. So we have to do a little bit of pre-thinking it through, but this would be the original problem. So if you're writing it down into your notes, do something to designate that as the original problem. Okay? And then we're going to work through, because I don't want you to be confused when you look back or you try and take a quiz or a test and think that the other piece that we're going to find is actually given to you. Okay? So we've got the problem written down. So the first thing, what should we do with this?
plug it in.
Put it on the picture. So we put that on the picture. That's an important step so that you see it.
I have a question.
Yes.
Why do you put it on the inside, not the outside?
It could go either place. It's just because there was a little more room there. It's not, there's not a specific designated spot. Alright, so if we're going to subtract and divide by 2, we're missing the other arc. How do we find
360
this?
minus.
360 minus, good. 360 minus 124. That gives you this arc, which is 236. Okay? The tendency of people is to forget that there's going to be one subtraction to find this, and then there'll be a second subtraction to subtract and divide by 2. Okay? Does everybody see where this arc came from? Okay? We'll take it to the next step then. We're going to have to subtract and divide by 2 to find this angle. What are the 2 measurements we're going to have to subtract?
236 and 124.
Good. 236 and 124. Divided by 2. 236 minus 124 divided by 2. You'll solve that down, and that will give you your angle ABC. Okay, so you're perfectly capable of doing that. You subtract the numbers and then literally divide them by 2. You know how to do that math. And we end up with 56 degrees. So that's the one little tricky thing about these tangent problems when they're both tangents, is that you're only given one piece of information, but then the other one you're able to find because of the way a circle works. So we want to look at another one that is traditionally a little bit tricky. All the rest of these slides are just that I did them one step at a time. So this is really just one more problem, and it's not really that hard. I just put things on really literally one little thing at a time. Does everyone have this one written down?
Yes.
Wait. All right, here's the other one that's a little bit tricky to do if you're given the angle and you're trying to find arc AB. This is another one that you look at, and sometimes students will think, gee, I don't really have enough information, but you do. Okay? So, what we should always do first when you're trying to find the missing piece is give it a variable. So we're going to give it a variable x and we'll put it on our picture. There we go. X is going to represent AB. Okay? Now, we don't have a number here, but we have to use the same process. So if we use the same process as before, what's this part going to look like? This over here is going to look like what?
I have a question.
What?
For the given, is there something that you call this or no?
Nope. Give him the picture with the little angle in here. Okay. So, who has an idea what's going to belong over here? And it doesn't have to be a number. It can be an expression. No, we're not going to use y, although that's a good idea. But in order...
360 minus x.
360 minus x. Before, we had a number to subtract from 360. This time, we just label it as 360 minus x. Because however big x is, that's how you would find it. But we will end up getting an expression in one variable that we can actually solve doing this. Alright, so before we took this piece minus this piece and divided by 2. We need to do that same thing. You need to take, Antonia, what's it look like?
30 equals 360 minus x minus x over 2.
Good. She said it looks like this. She said 360 minus x over 2 is 38. That's absolutely right. This is the part where people, if someone makes a mistake, this is where the mistake happens. Be very careful. You take 360 minus x, which is this arc. And then you have to subtract x again because this is the smaller arc.
Why is 2x?
Because, why is there 2 x's? Please pay attention, everyone. As I said, this is the trickiest part, and we have a question on it. From here all the way around to here is 360 minus x. Let me just get another color here so that we can, that's this one. So that actually is right here. And then we need to subtract the other one. So there's really two things. There's this arc minus this arc divided by 2 equals this number. So that's why there's 2 x's. This piece is 360 minus x. This piece is just a plain x.
Do we have to subtract?
Yep. You have to subtract because the intersection comes outside of the circle. So this is a good problem. It just makes you have to think it through. Now we need to put these together. Here's the other place people sometimes make a mistake. Minus x gives you minus 2x. You take away 2x. Sometimes students will accidentally cancel them out. These are not canceling out. There's minus 1 gives minus 2. Okay, so be careful. Your x's did not drop out. Now you have a problem that's hopefully a little easier to solve. Multiply both sides by 2 is the easiest on that. Multiply by 2. That gives you the 76. And then the next step is to subtract 360. So we subtract 360 and get negative 284. Then divide by 2. And you finally come up with your answer. It's nice that you have negative divided by negative because we're expecting a positive answer. And we get 142 degrees that way. So Even though you're given just one piece of information, even though you're just given the angle, you can still solve the problem. You just need to be super careful right in here and setting it up. Because there's 1, 2, 3 places that students sometimes make mistakes. So be careful. Watch out for those things when you do it. Okay?